All right, so let's now move on to our panel discussion. Let's hear from our industry experts on where are they making this big, bets and, and figure out, what's our opportunity for us to grow, right? Okay, I would like to now introduce our panelists, Gail Shepard. She's our Vice President of New Technology Group at Intel. She also leads the overall market vision and strategy for the Intel's AI platform. So Gail was the CEO and the chairman of Saffron Technology previously. Thank you, Gail. I now would like to introduce Ritika Gunnar. She's the vice president of IBM's data and analytics business. She's responsible for the offering management and P&L for offerings including Hadoop, Spark, and analytics. She's also responsible for defining IBM's next generation analytics capabilities. Thank you, Ritika. Eva Say is from Netflix. She's a director leading the big data services team. Her team architects and manages an ecosystem of core services that make up Netflix big data platform in the AWS cloud. Thank you. And our next panelist, Jennifer Shin. She's a founder of 8 Path Solutions, which is a data science and analytics company. She's also a senior principal data scientist at the Nielsen's company. And she's also a faculty member at the UC Berkeley. I don't know how she does it all, but we'll find out more. And I will be your panel moderator. And so the way we want to structure this panel today is, let's go over, hear from all these great experts, industry experts, right? We want to understand their perspective, and let's hear that for the first 35 minutes or so, and then we'll open up the last 15 minutes for questions. I know we are a little late, but we can line up the questions towards the end. Okay, great. Thank you all for joining today. So, I want to first let's get started with the market trends and and then where is the business, where are we heading, and where is the opportunity for women, and then figure out where we can grow, how we can grow, and what is what we should be doing, right? Okay, so. All right, so maybe Gail, with your background, I think I'm going to start with you. Okay. So what are the market trends in AI or machine learning and deep learning, right? So where is the industry headed? And what is the, say suppose you have a customer, use cases, and if they are changing their businesses and solutions because of, AI, what are their pain points as businesses are, increasingly start moving towards AI, right? So what's your, take? I mean, you have this background from Saffron coming into Intel, defining the strategy for AI platform. Perfect.
Great question, big question, right? So first of all, this is probably, in my career, the most exciting time ever to be on the forefront of artificial intelligence systems, distributed intelligence systems, right? So from cloud to edge and back again. We are similar to some of the people in the room and on stage. We are building solutions at Intel using a variety of machine learning technologies, whether it's traditional statistically based machine learning, deep learning, or associative learning, which is where my team specifically focuses. All of these learning mechanisms are coming in to businesses today, and I think that there's absolutely no industry that we can see that will not be touched by this, is not already being touched by this, and the adoption rates are different, right, per industry. We saw a lot of early adoption led by IBM Watson, frankly, in the healthcare and life sciences industries, right? Some profound things being done there to really improve the doctors and how doctors have information available to them that was never before truly organized in such a way that it was at their fingertips and they could make better decisions about how to care for their patients. All the way to precision medicine for cancer treatments, leveraging our own tumors to help inform how to treat our cancers. So these are profound. We work across industry, so we see many use cases in financial services, banking and insurance, for example, for really working on helping find the bad people doing money laundering and fraud, which affects all of us, to helping personalized services, to serving customers better, right? If we can treat each and every one of us as individuals that we are, rather than groups and clusters, then we can become much more individual, much more practical about what's best for us from a banking or anyone who's serving customers. I think two use cases I'd like to call out. We hear about robotics and autonomous driven cars and trucks and things like this all day long, right? So independent machines that are operating without humans. These are things that are in the news, and we're all participating in them very, very great ways. But there's a use case I think is very practical that one of our customers, an insurer, recently had a situation where there was a tornado that ravaged an area of their customers in Texas, and so they sent drones out to inspect the area right after it happened. So almost instantaneous evaluation of the damage that had been done, and they were able to correlate, of course, individual properties, both commercial and residential, with their customers. And by doing so, they were also able, by the visual cognition occurring in these drone systems, were able to identify the extensiveness of the damage and automatically queue up service repair people to go to these homes and begin engaging with their customers to repair and to make estimates, repair, get approval. And all of that happened very quickly, as opposed to the past where you had to get in line, you're the stressed homeowner or owner, business owner, you had to make the call, you had to file the claim, you had to wait for someone to show up and time would pass. Now all of this is happening almost, not real time, but near real time to serve their customers better and also to serve the shareholders of that company. So that's one example. One last example would be the National Center for Missing and Exploited Children, who's now able to use deep learning technology to do facial recognition of a child maybe 6 years ago with examples of potential candidates to be that child today, match them up so that the investigators do not have to do that. It's a long, lengthy process, immediately improving the operational tempo of these investigators to go find these children and get them off the streets and back into a safe place. Another great example. The challenges are still enormous, and we'll talk about those as we go, okay?
Very good. Wow. We're going to have a better world, right?
Yes, we are, absolutely.
That's what finally it is. So, Ritika, now in IBM, you work a lot on analytics, right? So how are these open source capabilities transforming the business models in AI, and how are they being adopted?
That's a great question. So when we look at the technologies that are out there and kind of the alignment of why we have the effects of every industry and every profession being reimagined because of AI, I think it's an alignment because of the way open source technologies are being used, the way we have very fluid mechanisms to be able to implement that, i.e. cloud or whatever distributed technologies exist today, as well as the abundance of data. And so when we take a look at how the market is really changing and how the adoption is really happening, 50% of applications within the next 12 months will have some form of AI in it, 50%. And then if you add that to why, it is because of the ubiquitous access to these open source technologies. Scala, Python, R, Spark, all of these technologies are so openly and readily available in the market today that we're seeing a network effect of growth in the usage of these technologies that are happening in these new types of applications and growth in the data science profession. Of course, the demand versus the actual supply of data scientists is definitely not in that equilibrium, but that's where all you women in the room make a big difference. But when we take a look at how that's really transforming these industries and professions, it is making it accessible to be able to have access to start building these new types of applications and using things like cloud and access to all data. Look, I think AI has been around for a long time, but if you look at what's changed, it's really, we've had it with what I would call proprietary or very, proprietary type of technology. And by being open, everyone has access to it. Number two, what's happening is that now you have the ability to be able to use that technology in ways that we couldn't with cloud and cloud usage. So, we are seeing a lot more usage of these type of open source capabilities all throughout. A data point, I particularly work with like Fortune 1000 companies. Every single company that I work with is using some sort of open source technology in AI. Every single one of them. Now, the adoption of that technology in terms of production workloads is dependent on the industry that you're in. Like some of them have, I would say from the data that we have, around 80% of these companies actually have workloads that are in production, and the 20%, it's not like it's not going to happen, it's just a longer lead time to be able to get there. But we see that access is really becoming more usable for everyone out there.
Very good. Yeah, I can see in the next decade, the world will really transform, I guess. Okay, so now we see, from the machine learning, deep learning standpoint, right? Now let me come back to the infrastructure side of things. We are in Spark Summit and we need to talk about Spark a little bit, right? So Eva, what are the market trends in the, as we are building this big data infrastructure or big data services, opens, the technologies, right? How do you see, the market? Here, and then also when you compare, how do you compare from Spark with other frameworks as you're applying machine learning, right? You do a lot of recommendation engine from Netflix. You guys do a lot of frameworks, or you may be using some tools. Maybe I don't know if you can touch on some of those. Mm-hmm. That would be great.
Yeah. So at Netflix, of course, we use Spark. That's why we're here. We have a lot of engineers on the ground. Giving a talk and things like that. So basically, you can see that big data technologies like Spark, we also use Presto at Netflix. They're very pervasive right now. A lot of companies are using it. These are open source technologies that has a lot of momentum. A lot of open source developers are working on it. They have become very ubiquitous, like Radhika is saying. So they are almost at the point that it is commoditized. They're very robust. The trend is basically now we are seeing a lot of cloud vendors or vendors, they're building infrastructure on top to make it more easier to be deployed in enterprise company, right? So you would see cloud vendor making it available as a service, you can pay as you go. So that's the trend. And at Netflix, we actually are running everything on Amazon Cloud. Some of the stuff that we are doing is at a much bigger scale that it would be more efficient that we build our own infrastructure on top. So we actually are building infrastructure on top. And if you compare Netflix with other internet companies like, for example, LinkedIn or Facebook, they all also have a level of infrastructure built on top of these big data technologies so that it is more open up to the whole company, data analysts, data scientists to use. So we actually have a layer of infrastructure that we build on top. We open source. We collaborate a lot with other internet scale company in the Valley to build those infrastructure. In terms of Spark use case at Netflix is very, it's actually everywhere. We use it for ETL processing. Mm-hmm. So for over 40% of our ETL processing is in Spark. The rest is in the more, the first generation tool like Pick and Hive, if you know about them. And then we also use it for recommendations, like Soumya is mentioning. We use it for recommendations. We use it for personalization, like what the ranking of content that we show to our members done by, machine learning algorithm. The roles that we show to our members are also done by that. So we use Spark for doing feature generation, training data models. We use it to evaluate, to use ranking metrics against the validation data set so that we know which data model work the best and put that into productions. We also use Spark streaming in order to do anomaly detection, trending, show that are trending now, and also we are moving towards more and more real time. We are trying to use streaming in order to do online model training as well. So it's being applied on a wide spectrum of data needs at Netflix. So the last question is, how do we compare Spark with other tools, the big data tools that we have used in the past? Basically, the way we look at Spark is more like an ecosystem. It's not just a big data processing engine. First of all, it is pretty language agnostic. You could use Scala, you could use Python, you could use Spark SQL to access it. And also the program that you write or the job that you write can actually integrate business logic with machine learning, and they can intertwine. You can graph it at the same time. And at Netflix, we also have a notebook environment, which is a developer environment as well as a runtime environment, so that developers can actually run the notebook. They could collaborate. They could add additional machine learning algorithms in the environment so that it works for their specific needs. So it's actually a very, it's an ecosystem of tools that all built into one, so that all the different needs a wide spectrum of needs can be satisfied. So that's an overview of an infrastructure that we built at Netflix.
Okay, great. Thank you, Eva. So now let's come to the data science portion of it. That's what we want to understand more, right? So Jennifer, you are you founded this data science company. You are doing a lot of things. You're also a data scientist, and you're teaching. So what do you see the future of data science, and why do you think it's so valuable to us? Maybe some of us, it's not too apparent to us. We probably want to understand. And how do you put, all these, big data technology, Spark and machine learning, deep learning, how do you put all these together, and how do you use it in your line of work?
Yeah, so I just did a webinar for City University of New York about the role of statistics in data science, because there's a lot of confusion, a lot of debate about, is it data science, is statistics the same thing? There's two schools of thought. Some people say it's the same thing, other people say it's not. So I did a webinar talking about where statistics fits within data science. I think one of the things that kind of is confusing is that data science is a new field. So we're still developing and still figuring it out. Statisticians were generally the ones that did data mining for large data sets. So they're kind of the most likely people to be able to go into the field and really do data science work. That doesn't mean that they're the only people, but I think that's why you saw so many statisticians going into that space. It was a sort of natural jump, right? They're already working with data, already programming with R, and so now there's industry demand, it just kind of makes sense, right? I think what is really interesting to me is I've seen over the last few years that now machine learning has become more prevalent, so more people know about it. And now that people know about it, I think the standard of what the expectations are is changing. By that I mean it's not as impressive anymore, right? Like everyone has access to the API, everyone can run it themselves. So now you start thinking about, well, what is this data actually saying? What is the API actually doing? How is the data actually being manipulated? I think that's where things like statistics and mathematics come into play, right? How do we quantify the impact? How do we quantify that an improvement has happened, right? So we know one algorithm is better than the other, but how do you actually check that? How do you verify that? How do you confirm that? And that's where there's room for a lot of, I think, science to kind of have an important role in data science, to be able to find new ways to measure things, right? New ways to standardize things, new ways to be able to work with data in a way that's not directly linear, but much more, in a faster, less traditional sort of way, right? So for me, that's kind of where it's exciting to be able to build sort of like a more abstract model where you can actually work with data faster and not have it be so one-to-one. You can kind of have a more efficient algorithm and not have to look at every single data point and, to kind of do it that way. In terms of academic space, I think that's another place where you see more statistics departments, math departments getting involved in data science, and they're starting to develop coursework around, the work they do, which is also very exciting just because my background is in math and statistics. And from a statistician standpoint, I think it's interesting to see what happens with the field, right? Because there's a lot of debate about is it statistics, is it data science? And so it'll be interesting to see where the academics actually go with that. I think, for instance, Yale just renamed their stat department, I think, the data science and statistics department, right? Whereas other schools have not done that. Other schools have kept the two separate. So it's going to be, I think, something where I think especially for those of you who are interested, it's a great time to be going into the field because there's a lot of things that need to be defined. There's a lot of things that need to be determined, and there's a lot of work in that respect in terms of both being able to develop models and do the quantitative work, as well as in terms of operational standpoint, right? Where the impact can be made, and so there's a lot of room for growth.
Okay, great. So I think it's fantastic to understand, where the market is headed and and how, data science is so valuable, and, how these, all these technologies are absorbed and adopted, right, in the industry. I think it's great to understand. So now let's, probably several of us probably have this question about, okay, how do we become a data scientist? You teach in UC Berkeley, right? So are there any programs in place? Do you have to have a degree of some sort? Well, you got to have some degree, but what do you need to do? I mean, are there any special programs that we can, people who are not probably in the field, but they want to become a data scientist? Now that we have heard so much, the future is so big, right?
Yeah, so I started working with data, over 10 years ago, and when I was in school, there was no data science program, just didn't exist, right? So I had an interest, took my undergraduate majors in economics, mathematics, and creative writing, and I have a graduate degree in statistics. Now, when I had my major, everyone said to me, why would you major in that? That sounds crazy to them. No one had ever combined those fields together. But for myself personally, I thought it was interesting. I thought you need to be able to communicate about things like data. And you also need to be able to work with data, right? To be able to find and calculate, measurements off of data. So for me, it was sort of a natural sort of interest to go that route. And now that data science is a field, it turned out worked out pretty well. So I guess, the thing is, I guess these programs that are out there are relatively new. So I would keep that in mind, right? They're still being developed, right? A lot of academics are still trying to figure out where's the right balance in interdisciplinary work, right? How much of it should be within the scientific field versus, say, in a more applied field, or more applied department. So I think you have to be cautious about going into these programs. I don't think you should just go into a program and think, if I do this coursework, I'm going to be a data scientist, I'm going to be great. You'll have a degree in data science, right? Whether or not you'll be great at it is something where you should keep in mind, your skill sets will actually determine that. Right? By that I mean you can get an A in a course, but if you go to your job and you can't actually perform the work to that level, that's a problem, right? So developing the skill sets is really important, and caring more about that aspect of it, I think will, in the long run, be more important than, say, what grade you got, right? A lot of these data science companies do technical interviews. I don't know if you guys have actually experienced it, but I've been through the wide range of everything from coding to case studies to presentations, and so you're going to have to kind of present data and actually show that you can work with the data. So there's not much shortcuts you can really take in that sense, right? If you've never worked with data, then you'll get stuck right in the beginning. If you work with data but you don't understand statistics, they'll probably ask you a question where you'll get stuck, during the interview and not know how to answer it. And then if you don't know machine learning, then you won't get to that end of it where, okay, so you've shown you can do a regression, but what about a regression versus, say, random forest, right? So these are questions that, they can ask you, and so you really need to spend time, right? And if you want to be in data science, really dedicate time. It's not going to be something that's really fast and easy. It's going to be something where you're going to have to kind of explore for yourself personally what you want to learn within the field, right? Because the field is very vast. So there's going to be different aspects within the field that you're going to feel more of interest in. So it's kind of half self-exploration about what do I want to be doing, how do I want to do it, and just kind of exploring that, as well as being able to then align that with what jobs are out there in the industry, right? Because no one actually goes out there and does all of it. And I have the skill sets to do all of it, but the reality is there's not enough hours in the day to be doing all of it in any one particular job.
Okay, good. Thank you. So several of us are in this boat of, okay, I don't have the data science background, including myself, right? But I have a computer science background, and I have been in the profession several years, 17 years now. So if I want to become, a data scientist, I've actually, several people have come and asked me in the previous meetups. So how do you, if you're already in the professional field, right? If you want to reshape yourself to become a data scientist, what do you have to do? What kind of experience do you need, or what kind of, technical skills, or what do you need? To become one, right? So is there something, and be successful? That's what we want to be, right? You don't want to move into something and not be successful. So how do we, perhaps if you want to.
Do you want me to go ahead? Okay, so I'm going to answer that, but I want to ask everyone in the room a question, maybe do a little bit of participation here. How many of you consider yourselves to be data scientists today? That is a really good number. That is a really good number.
Maybe one
How
more
many
question.
would consider themselves engineers or technologists? That's a good majority. You know, I ask that question because if you are founded in a base of technology and being a technologist or an engineer, we all know that technologies change so quickly in the market that if you're gonna be successful and if you're gonna be in it for the long term, you have to figure out how you have your continued sustained learning. So for me personally, I actually have a background in computer science. I have a background in technology. I've done development for years. And I was told a few years ago, you know, I had a background in data. I ran the data warehousing business. And it's like, you know, we're doing things in data science. We want you to be able to lead our data science practice. And I didn't have experience at that point. But I definitely have the drive and the will, and I knew where the market was going. I had some knowledge of some of our in-house technologies, but I knew the market was really thriving with a lot of these open source technologies that we talked about. And so there were a few things that I personally did that I know that many of you, if you're going to keep up with your skills, you're doing the same thing. And that is, one, because of where I was and the type of products that I was creating and the type of partnerships we were doing, I aligned myself with industry experts. So the guys who we ended up doing partnerships with at IBM, our studio, H2O, many of them, I took their senior leaders and we actually partnered and trained each other on technologies. And so they were my mentors. They were my teachers, number one. Number two, I hired people who were absolutely awesome at this to surround myself and to teach me. And through them, we would work on projects and I would take night courses on how to program in Python, how to use Spark to be able to do some of the ETL transformations that we wanted to be able to do. I did that personally myself so I could root that with the type of products that I wanted to be able to create for our business. So surrounding myself with people who were much smarter than I was at it and using them as mentors to teach me, taking night classes, and then I had the third option of being able to work with customers and clients in their use cases to really understand how to apply that. Data science is one of the fields that I really believe is a nice mix of not only being a great technologist, but being a great communicator, because you're trying to transform what you're understanding in terms of business problems into the technology, and then trying to be able to work across the business to really understand the data, to be able to create the right models, to be able to leverage all your technology skills, and to be able to use machine learning to be able to drive the right outputs. So, you know, when it comes to being successful as a data scientist and to be able to build the skills, I think a lot of it is about the tenacity and the will that you have. And the great thing about a lot of it being based in open source technologies is that the material is out there for you to get started. Like the material exists out there for you to get a foundation on anything on your own without having to spend much. It is having that tenacity and that will to be able to do it that makes the biggest difference.
That's great. Taking night classes, gosh, women are hardworking and multitasking, working all the time, right? Fantastic. Gail, do you have something to add?
Well, now that I've heard that, I'll shift what I was going to say. But I think one of the really cool things about this organization is you say diversity of gender, but I think what's really important is diversity of thought as we're building artificial intelligence solutions. And so, so as I look at the organization that I have responsibility for, and then I look across Intel at this vast, brilliant organization that we have as a company, you can't walk down the hall and not bump into an engineer, a data scientist, a machine learning expert, et cetera. So one of the things that I think we really, well, as I look at our team inside Saffron, one of the best combinations I've seen creative contribution to our application development is actually the engineer that is also a data scientist, the engineer that was also a physicist, the engineer that was also a mathematician, the engineer that also brought these rich data science skills to the table, and business experience, whether that's industry experience, they understand how supply chains work, or they understand the manufacturing process for an oil company or whatever it might be, to bring in some of that industry knowledge as well. So, to reinforce that point, the combination of these skills are great. The other thing I would add into this is got to be a little bit about the biology of how the brain works. I don't know how you can be a creator of machine learning applications and not understand have some fundamental understanding of how the brain works. So I encourage you, this might be extracurricular reading, and you might start with Eric Kandel, one of the best neuroscientists on the planet, but go understand that so you can have a conversation with the neuroscientists who are all on our teams today and are influencing the vision for artificial intelligence of the future. This is just a fun thing to read. It's about our own brains. It will enrich your life personally as well as professionally, so include that in the repertoire of things you should do.
Awesome. I'll definitely go read Eric Kandel's book.
Eric Kandel. It's a good place to start. Yeah.
All right. Wonderful. Thank you. Thanks for that. Now let's, focus this discussion a little bit on the engineering. Let's broaden this, spectrum of this, right? Now, what are those differences between this data engineering and software engineering as you're building, the big data infrastructure? Maybe if you can comment on some of that, Ava, and what do you need to have that good skill sets to become a good data engineering?
So that's a good question. So basically, there are different kinds of, like in the big data world, it's a big spectrum of roles that we could have in. You could be an infrastructure engineer, you could be a data engineer, and then to the other spectrum is data analyst and then data scientist. So all these are interesting roles in the big data world. The difference, so infrastructure engineers are basically, that's my background. I am an engineer for many years now. So basically, they are the one who built Spark. They're building the back end of Hadoop and all that, and building infrastructure in the cloud. So these are really hardcore distributed system engineers that understand how to make things scalable, highly available, and make it work at large scale. And data engineers is a very special role. I myself is not a data engineer, but I've seen a lot of data engineers, they actually have engineering background. But the specialty is actually making different things work. They understand how the different system works at large scale, what is the stress point, what different system is good at, what database is good at, what Hadoop is good at as a storage system. They understand the trade-off. They're able to actually syndicate data from different systems and make it available for data analysts and data scientists. So they actually have a very broad spectrum of skill sets. They have some math background, they understand what the data analyst needs. They actually also are they are very resourceful. They usually are very good at understanding the problem space, making everything available for the consumer. So that's like a bridge between the engineering and data analyst and the data scientist role, which is more leaning towards statistics, and then all the way into building new algorithms and coming up with new approach to look at the data. So that's the difference that I see it, and some of the most successful data engineers actually crossing a lot of, like they have cross understanding of engineering and actually data consumption, how it's being used. So those are the most successful data engineers that I've seen.
Okay, good, very good. So how many of you want to become a data scientist now after hearing all these?
I think half the room already was.
The remaining half, I probably want to consider at some point. All right, fantastic. Thank you so much. I think we'll take one more question and then we'll open up for the questions. So I think it's great to see. I think there's a huge market here and there's a big opportunity. And women, I think we want to catch this momentum, right? We want to ride the wave and catch this momentum and make use of this. But then, we are so busy in our lives, and especially women. we got to juggle with so many things. I want to be a great mom. I want to be great, at career. I want to, be kind of do everything. A lot of things. We want to do. We want to juggle around things, but time is so important. Time is probably the most critical, the most critical thing, and it's the most valuable currency today, right? So how do we juggle all this? Or, what is that fastest path if somebody wants to become a big data scientist, right? Can you, is there a clear path, to get to data science, and can you be successful, and can you thrive in this field, go all the way up to the CEO level? Right? So, any comments?
Dare we? There's no silver.
You have the microphone.
I have the mic. Okay. There's no silver bullet, right? It's all about priorities and where we are in our lives and what's important to us. So I don't think there's a fast path, Jennifer. Is there? You don't know? No. Yeah. Start your own company. There you go. Good answer. Yeah. Start your own company.
Yeah. Now, keeping it going, that's the hard part with that sort of solution, right?
That's right.
Yeah.
Yep. But I think, so as we talked about this prior to this panel actually happening, and our conclusion, I think, was that there's no silver bullet. It's your passion and your priorities and your life and where you are. And if you have young children and you're trying to juggle all that, this may be something you get to do it between 10 p.m. and midnight or so, right? But it's, again, it's all going to be based on that. There are lots of online programs to go to, right? And so you can go online, you can do it on your schedule, on your time, you can talk to your manager, your HR departments, wherever you may be, and figure out, do some career planning, right? And state this as an objective, and they will help you. We do that at Intel. So there's a variety of tools available to you depending on where you are. But I think leveraging the online capabilities, because I do so much of my learning by just research, online research, and staying current and up to date, is all self-driven, and it's based on, that 10 to midnight hours and that 5 a.m. to 7 a.m. hours where I actually have some quiet time to do those sorts of things. So anything's possible, right?
So that's right. There is no silver bullet for this, right? I can be a great mom today, but tomorrow it's okay not to be a good mom. It's okay to be great at your career, right? It can't be perfect every day. So and day after maybe I'm a great doing my hobbies and doing my socialization, whatever I want to do. So I guess I think my advice is not to be perfect.
That's great advice.
Well, you'll never achieve perfection, but I do think focus is important. And if doing something in this field is really important, then you find the time. I'll give you an example that we're doing right now in our family. I have a son who's 10 years old, a daughter who's 8. They've been taking their own Python programming classes at this age. Yeah, well, we come from an engineering background. And my husband, who stayed at home so I could do the career thing, he took a look at, we were like, look, no more Minecraft unless you're programming something. No more, you got to start doing, something that's productive, and we'll give you unlimited computer time. And we took a look at it, and we're like, we could actually do something as a family, and you start creating things that create value, and then family night becomes, okay, let's all figure out how to do something together, like creating Python. That's great for me, from what I do. It's great for the kids. My husband happens to teach the coding classes within school. But I will tell you this, as females, the one thing, and it's not related to your question directly, but it really is something that I take to heart that I want to impart on all of you. We sent our daughter to a Python programming class recently, after school program. And she came back after the first day and said, Mommy, I did not like that class. It just, I didn't like it. And I thought, why didn't you like it? My son came back and he was just like, I love it. Well, then I realized I was like, so what's going on? She said, there were not any other girls, and nobody really wanted to play with me and do it with me. And I was like, oh, when we think about really promoting girls in technology, in data science, in these type of engineering programs, we need to create a stigma that it is okay for you to stand on your own and be your own, and then encourage friends. So now I try to get another girl to do it with her, and they don't have to do the projects of Minecraft, which she doesn't care about, but something more along the lines of how she can change and do something that is really important to her, but use technology to do it. Look, technology is going to be in every single person's career trajectory at some point or another. So figuring out how to make it fun and applicable to something that is meaningful to our girls is something that is so important. For me at IBM, it is about like the cases that you talked about how Watson is really transforming how we do healthcare, how we do banking, how we're changing the world. So how does that become applicable to an 8-year-old girl? How does that become applicable to a teenager to where they can use technology to really advance what is important to them?
I want to add a little bit to that, which is, it is true that for some reason in America, it sounds like it's not cool for girls to be in technology. That's something that I only know when I come to the US, because that's not true in China or in India, right? I see Sudra laughing. So that's really unique in the US. So at Netflix, we actually have a program where we bring high school or middle school girls to Netflix and show them how women actually can make it work, like end to end, how we actually do encoding and showing building the UI, the back end, and give them a story of how we actually make Netflix work with women engineers or women technical employees. So I think that's a good. I don't have a girl, I have a boy. But I think that is a very good thing to start early, to let them know it's actually cool to be in the field.
That's a great program. Do we have that at Intel?
Yeah.
Yes. Yeah, and I love the Girls Who Code program. We have lots of volunteers in that organization as well. It's really a great place.
The science fairs and,
to get orientation, right. The only question I have is, how do we get our girls to work when they're in these environments where they're somewhat isolated, to find the guy to work with, the boy to work with, right? So that this joint working together culture of men and women starts very, very young, as opposed to something learned later. I'm older than everyone on the panel, and I grew up in a world where I was the only woman. I'm still often the only woman executive in many meetings, sadly but true. And and I even today feel that somewhat isolation that you're describing, right? And so it's really, so I have to be the one who reaches out, otherwise it will never happen. And build those relationships truthfully. I mean, it's rare that it's not me who's the instigator of that. So anyway, I just, that's a different problem that we can't solve here today, but one we have to think about consciously as we grow up our girls.
You can come over to the microphone and start lining up for questions, please.
Eva just said that she has a boy, not a girl. Yeah. I believe a lot of us women do have boys. So telling them that, hey, look, play with girls, yes. Include them, and they are the only person there, make them feel belong here. So that is very important. As we raise our girls, we sometimes forget that we need to raise our boys as well to be inclusive.
Yeah.
So I'll say from my experience, it's a little bit different. So I guess maybe because I went into STEM. So I started working or trying to go toward math graduate programs and think about doing PhD probably later. So I think I was like 25 when I graduated from undergrad. So it's later than most people. I'd taken time off. And, the perspective from my professors were, you're kind of late for you, you're kind of old for this, right? Took theoretical math at 25, and and now I do actually do math research. Like after this event, I'm going to the ISERM, which is the Institute of Computational Experimental Research in Mathematics at Brown University, right? And doing a workshop on probabilistic computing, right? So, my approach when I went into STEM was to kind of figure out how much of the stuff you hear about, there's not enough women and there are all these programs and all that stuff that's out there about, being in STEM and the difficulties, how much of it is true and how much help is there? I found is, at the end of the day, you need to be able to do the work, right? Bottom line. All these programs are great, they'll help you, but, when you're in a PhD program or you're at, the top, right? They're not going to give you a pass just because you're a woman. So along the way, you're getting some of this help and you think that you're not going to have to make up the differential. That is where you will fail in your career. Because at some point, you're going to have to put in the extra work, and it's going to be extra if you are behind, to actually make up the differential and have the skill set to be able to compete out there. Because, you could not develop those skills, but then you won't get paid as well. You won't have as much leverage. You won't be able to negotiate. You're not going to be as good as your male counterpart. And in my view, my goal was to actually, get into the field and do better than the men. Because I thought about it and went like, they're not going to, if there is a bias against women, then you have to beat them. You can't do just as well as them. That was not going to help you, in my view, get ahead. You have to do much better than them to be able to prove that you deserve to be there as much as they do. So for me, I feel like that has been helpful to be able to go into it and go, I'm not going to just do the bare minimum. I'm going to do more than the bare minimum. I'm going to do better than the top performing guy in the room. I'm going to do better than my male counterparts. And the thing is, when you do that, then the men tend to respect you, right? Then they want to work with you, and they'll actually actively want to be a part of your team. So, and for me, that's just been my experience. I don't know, I guess, I guess it's a little bit untraditional, I guess, from I don't find many women have this sort of experience in their career. I think the other thing for me was, I went and did this stuff much later, right? So I graduated 25, and one of the things I had to realize was, if I really want to be in the field, then things like having kids has to kind of come later. I mean, that's just, it's nice, the idea of getting married and having kids and all that and having all that personal life stuff. But at that point, I had a relationship, and I went, I'm not going to feel comfortable having kids unless I can give them the time and attention. And for me to be able to do that, I need to commit earlier in my life to the career, right? To actually getting these skill sets and making up differential. So I kind of went in 110% and took it on as, I need to get a place in my career where I have a high enough title that if I decide to take a break and have kids, I can go back and get a job and not have to feel like there's, some inequality there, right? Like, for instance, right now as a senior principal data scientist, I'm at the director level. So if I decide to go have kids, then I can get a job and still have that skill set that's more than just, sort of, again, the bare minimum, right? It's a very, the years of experience has given me more of a buffer to be able to go through, do the things that I want. So I think if you want to do whatever it is that you want to do, it may not be having kids, it could be something else. I think going 110% and really doing as much as you can to be able to then have some room to have sort of options, right? Other options in terms of what you want to do with your life. I think that's proven for me to be, very helpful.
Okay. Thank you, Jennifer. Let's take some questions.
Hi, my name's Christy, and as a former Splunk executive and more recently at Versiva Data Science as a platform company, I haven't heard the panel talk very much about other positions outside of data science and engineering. And while I know that's where we have a lot of catch up to do because there's just not as many women in that area, I really find that there's a whole company to support when you're at startups or more advanced companies that focus on big data, and that could be marketing or it could be sales or lots of other opportunities. And so I would love to hear the panel talk a little bit about the access to those roles in addition, because I love to encourage women to get involved into the very technical roles, but not everyone, whether you're a woman or not, is well suited to that. And there is a whole nother world of roles that keep you in that big data field. So I would just love to hear sort of your thoughts about that.
Okay.
Well, there are many opportunities, right? So as you enumerated, it is an organization, whether you're a business unit inside a large company or an independent organization, a startup, et cetera. And what we're currently, I'm currently thinking about our women. We have women leadership here from Intel Saffron, Jay and Mary sitting there. Mary leads our product engineering team, and Jay leads our client services organization. They have extensive computer science backgrounds, engineering backgrounds. They could do each other's jobs. And just amazing history. So in those organizations, we actually have a really reasonable representation of women in both organizations. We're very lucky. And Wei Ling actually is sitting next to Jay, and she's in Jay's organization, and Polly sitting next to her, who's in my direct team. So we don't have the diversity problem in those roles. Where I'm seeing a diversity issue might actually be in sales. And in pre-sales, interestingly.
Yeah, that's what I was
I can
thinking.
see.
Ritika
Yeah,
is
there
in
you
sales.
are. Okay. Well, what are you doing?
That's interesting. Okay.
Yeah, it is interesting.
It's IBM sales, not Intel
Yes,
sales.
I understand. So, but anyway, I find that to be an opportunity to, for me, one, to understand why And then two, is it what we're selling, because it's data science heavy or AI heavy, or is it something else? So I'm looking at that, but that's where I currently see the void in women in our particular line of business. So did you want to comment on that?
Okay, good. So yeah, let's take another question.
Hi, my name is Sandy. I run the data team at IFTTT, which is an automation company. So we have this interesting problem where, it's a super nerdy company, right? It's all about gadgets. I'm there because I'm a nerd. So we've decided that we're like, hey, we want our product to be used by not just nerds, which means that we want our both employee base as well as user base to be 50% women, right? So that's a far stretch. So everyone's super on board. We're like, okay, great, let's go hire more women. And then when we started looking at the incoming resumes, what we realized is that there's literally one girl for every 9 applicants who are men, right? So, it's kind of, we're trying to figure out, this is, if you follow this trend, you can end up with 90% men and 10% women in the company, which is exactly what we're trying to fix. Do you have any practical advice, right, on we are committed to, hiring more women in both data as well as other, functions. Do you have any practical advice on how do we actually source or hire good women candidates so that we can actually get there now?
Wow, okay.
Well, yeah, I think this is a great forum in the first place, but there are areas and groups you have, this whole Women in Big Data group is definitely a place. I am part of a few organizations that are like this, like even online, Women in Tech, which is like a Facebook internal group. I have hired 3 data scientists from there for my personal teams. And so for me, there are groups where women are coming together, and I have found phenomenal, knock your socks off, best type of skills. And so I think you look for those kind of groups and then start grooming from there. Yep. That's what I have personally done. And I will tell you that I've sourced at least 3 in my previous role, and there are a couple more that I'm hiring as tech sales folks in my new role that I've used.
No, actually, a lot of women in the Women in Big Data, in the events and meetups that we go off, many women have taken a break in their career and they're looking for jobs. And we actually recently opened up a job posting page on Women in Big Data. A lot of qualified candidates are coming in and they're looking for jobs. And we have a few companies who are already, Intel is one of them. We've started posting jobs. So, I guess diversity hiring shouldn't be an issue.
Sorry, just as a follow-up, I think do you see it as we have this pool of women, data engineers, data scientists out there that we just need to hire more aggressively from? Or is it more of, do we actually have to take more chances on people who want to be data scientists or data engineers who may not have the perfect resume? Maybe they didn't come from, I didn't have, enough experience in data science to, actually get hired, to be easily hired as a data scientist. How do you see us growing that pool?
Women have this tendency of not really selling themselves too much, right?
Can I add one thing to that? Look, one piece of advice that was given to me that I completely see now, because I see it in myself as well as my peers. A woman looks at a role, she sees 10 criteria, she fits maybe 5 of them, she won't apply for the job. A man sees a criteria of 10, they may be
1 or 2
applicable for 1. They go ahead and say they're the best at it, right?
Yes. See, that's
the reality of the situation, but never give up on your standards. I would never hire a candidate that did not meet the standards I need, but I would probe whether they have what I want. And I would do that for the 9 applicants that you got that were potentially male. The reality is that your pool of valid candidates is probably a lot less. Now, I still think there's a huge discrepancy between people who are actually, between males and females in terms of those that are qualified for that role. But I think part of that goes back to promoting that community of technology. And honestly, I actually think it starts in the much younger generation, like my daughter at 10, to be able to say, don't go play with your, look, technology, we can do fun things with technology now. I think that's where, when you look at how you really transform cultures and people, it's at that generation.
Yeah.
I'm sorry.
Seriously, we think we need to be really excellent at it to even ask or deserve a promotion, or go and apply for a job, right? I think there is that. I've seen there is a little bit of a fundamental difference between women and men, how they look at things.
Yes, I used to do that actually. So exactly what Ritika just said. Like I used to look at the job descriptions, and I started out in management consulting. Right? It's very competitive, and it is mostly men. It's, I did operations strategy. So but then they would actually, and that's exactly what would happen. Like they'd see 2 out of the 8, and be like, oh, I got to convince them about the other 6. And that's the approach. I never felt very comfortable doing that. But you still try. But here's the difference, I suppose. Like I tried it. I sucked at it. It was terrible, just the worst. But but I kept doing it though, and trying to do it for one thing because that's what they're doing. So you got to at least try to do what they're doing, or you're just out of the game, right? The other thing was, I think over the years, though, I've now developed those skills. So like right now, I'm interviewing at a couple of places, and I meet all the requirements. So I think I've made it a sort of a goal of mine to be able to get there, and in the meantime, play the game, right? Do what everyone else is doing. But if I don't feel comfortable with that, then the middle ground being that I'm going to go develop those skills and hopefully get there. So I think it is true. Like you have to keep that in mind when you're interviewing, because the men are more likely to be, they're not going to tell you maybe where their deficits are. So if a woman is there in an interview and says, outright what it is, for one thing, I'll make a comment and I'll tell her afterwards, when you interview, I would consider maybe phrasing that differently. Or I will, maybe you're not going to hire them because that is a gap, but I will make it a point to actually give her some notes about what she may want to think about for her next interview, so that she can then go to her next interview and have a better chance, right? So I think even things like that, or even if that you do hire women and they're on the team, I think just being aware that sometimes you just have to explain it to them, and then by explaining these little things about what they're doing that may make them less competitive, over time, once they catch on to that, if you have more women in managerial roles, I've noticed a lot of women then will feel more compelled to apply to those companies. Like IBM's actually a great example. I think IBM's one of the companies where women are, I've never seen anyone have that issue like with IBM, and I think a lot of their distinguished engineers are women. A lot of the people who develop patents are women. Right, and so I see that the younger generations, they go into the IBM interviews and they don't feel like that's going to be sort of an issue. They kind of go there going, well, yeah, they've done it. I want their career, and they'll do that. So, and then I think on the other side of that, if you're trying to hire more experienced people, I find that places with work-life flexibility, if you are willing to let them, again, not lower the standard, but say you can work from home more days, that'll usually get more, women applying for, higher level positions, because that tends to be where their focus is.
Okay, so we probably need to wrap up in a few minutes, maybe 3 or 4 minutes, I guess. So we'll take another question. I'm not sure if we can get through all the questions, but our panelists will be available, I think, offline. So please go ahead.
So this is maybe not a gender-specific question, but so you guys talked a lot about how a lot of data science skills can be self-taught. And I mean, there's also this fact that the data science industry is expanding really rapidly, and it's a really great time to be entering the field. How important do you see getting a higher degree to being a data scientist now and in the future?
I look at projects. I think the thing about the data science industry and open source is you look at outcomes, and a credential of a degree may be, it may be important for some people. It depends on who the hiring person is. I've actually hired people that don't have actual degrees, but have showed me portfolios of projects, or they're committers in certain open source technologies, or they have actually shown what they've done. Look, I think in this day and age, because, again, I'm gonna go back to things are open source cloud and all data, you can have projects that actually showcase for yourself probably much better than a college degree would. I will tell you, people who I have hired that sometimes have the college degree don't exceed the people who actually have said, here's my portfolio of stuff of what I've done. And I think that's the great thing about where we are with technology to say, is that your outcomes matter so much more, to where I look at what projects have they worked on, what are they doing in the community, how have they built those kind of projects, more than I do on where did they graduate from and what was their GPA anymore.
Yeah, another thing to keep in mind is the degree is only the beginning, right? I already forgot what I learned many years ago. So the truth is, this technology is transforming itself every few years, right? Trend change, like back then it was database, now it's big data processing system. Before when I was learning programming, it was procedural programming, then we pivot into object-oriented programming, and now we're talking about functional programming. So the industry is moving, so that's why I think they were talking about more self-taught, because you can never learn enough at school. I mean, it would just give you a foundation of how to acquire knowledge, but those skills actually you need to keep pivoting and keep changing, and that's where the learning actually come from. It's just, we need to continue to learn, basically. That's the trend.
And very quickly, Jennifer would tell us that data science, advanced data science programs are very new. I don't have a single data scientist on our team that is a trained data scientist per se. They have physics backgrounds, computer science backgrounds, et cetera, et cetera. They became data scientists, but that's not because they were trained to be one.
So I will say these programs are new. I think the first data science graduate program was probably 2012 was the first one. And so they're all popping up, but again, it was an industry demand that they're trying to meet now. They're like, oh, industry wants this data scientist, well, we'll train them. And so it's kind of the approach that a lot of universities have taken. I think the thing is, if you wanted to do more research, right, you want to be doing the research side, then PhD is going to be more important, right? They're going to probably not hire you if you don't have that research background. And so if you want to be sort of like expert in this particular type of AI that's being developed, and you want to develop a better neural network, right? In that case, you might need a PhD, and they may not consider you for that role. If your goal is more to be on the industry side and on the business side, I think developing sort of these technical skills and then using them, right? In my case, I started a company, and I started developing patents, like technology patents. Now, I couldn't get a job doing technology, 5 years ago, right? But what did I do? I went and kind of proved that I can do it by developing patents and developing partnerships with other companies and going that route. So if you want to be more in industry space and kind of doing things and more operationally implementing, in that case, you can actually use what you do know and find other ways to prove that you're expert in it, right? Getting a patent is sort of a way of showing expertise, right? Being able to put thought leadership out there is another way of showing expertise. Whereas if you wanted to go really hardcore research, then a PhD probably would make much more sense.
Okay, thank you very much. Unfortunately, I think we are out of time. Sorry, we couldn't get all the questions, but I think there is another session that's going to get started soon here. So, but we can be available outside. If there are any women in big data generic questions, please come over. Ask several of us. Regina is one of our committee member, and Carmen and Bhakti, and several of us are here. Thank you very much. I hope you found this useful. Thank you.